The maps should have looked ordinary. As astronomers plotted more and more galaxies across the sky, the expectation seemed simple. The dots would spread out broadly, filling space without any obvious pattern. Instead, strange shapes began appearing. Long stretches packed with galaxies emerged across the maps. Between them sat enormous empty regions where almost nothing seemed to be there. The picture stopped looking evenly scattered. It started looking divided. The more the maps grew, the harder that impression became to ignore. What appeared on the page was not a gentle distribution of galaxies. It looked more like vast walls surrounding immense voids. Entire sections of space seemed crowded, while others appeared strangely vacant. That immediately created a problem. If the universe was expected to look broadly uniform on these scales, then the maps were showing something very different. The familiar picture no longer fit what was being observed. At first, there was an easier possibility. Maybe the structures were not real at all. Maybe the maps were incomplete. Maybe the pattern was a mistake. But the shapes kept appearing, and an unsettling possibility began to take hold. Something large seemed to be organizing where galaxies ended up. The possibility of a mistake does not disappear all at once. The maps are checked again. New surveys begin. Different groups look at different sections of the sky. The expectation is straightforward. If the strange walls and empty regions came from an error, the pattern should start changing as new observations arrive. Instead, familiar shapes keep returning. A survey produces a map. Long structures appear. Another survey examines a different area. Similar structures appear again. The details are not identical, but the overall picture refuses to go away. Dense regions connect across space, while enormous gaps remain between them. That creates a growing problem for the simplest explanation. Errors are supposed to fade when observations improve. These patterns do the opposite. Every new map gives them another opportunity to disappear, and they keep surviving. The walls remain. The filaments remain. The voids remain. The pattern is no longer behaving like a mistake. It is behaving like something the observations keep uncovering. The pressure shifts. The maps are no longer the problem. The pattern is. The easiest escape route starts closing. The patterns may not be trapped inside the surveys at all. They may exist beyond the maps themselves. And if that is true, something is shaping where galaxies gather and where they do not. The strange pattern begins to look less accidental and more organized. As larger sections of the maps come into view, some of the crowded regions no longer appear isolated. Thin connections seem to stretch between them. What first looked like separate concentrations of galaxies starts resembling parts of a larger arrangement. Clusters that appear disconnected now seem linked by faint structures. The image changes. Instead of scattered islands surrounded by emptiness, the maps begin to resemble a network. Dense regions sit at key points, while long filaments extend outward, connecting one area to another across the darkness. That shift carries an immediate consequence. For the first time, the structures stop looking independent. They begin looking connected. The walls, filaments, and voids stop looking like unrelated oddities. A possible pattern emerges that can hold all of them at once. If the connections are real, then galaxies may not simply be scattered through space. They may be arranged along hidden pathways that tie distant regions together into a larger framework. The picture suddenly feels more coherent than before. But coherence is not confirmation. The apparent network still depends on what the observations are showing, and as the maps continue growing, one uncertainty remains. Will larger observations preserve this emerging pattern, or will it begin to break apart? The next maps do not weaken the pattern, they strengthen it. The surveys expand farther across space, adding more galaxies, more distance, and more opportunities for the apparent network to fall apart. If the earlier structure was exaggerated, the new observation should expose the mistake. Instead, the opposite happens. The larger the maps become, the easier the pattern is to see. Long filaments extend across regions that once appeared disconnected. Dense clusters emerge at key intersections. Vast voids remain between them. Features that seemed uncertain in smaller surveys now appear with greater clarity across much larger areas. That creates a consequence the coincidence explanation cannot survive. A coincidence can repeat once. It can sometimes repeat twice. But as independent observations continue expanding, and the same arrangement keeps emerging, the idea of an accidental pattern begins losing ground. The network does not shrink as the maps grow. It expands with them. The walls remain. The filaments remain. The voids remain. What once looked like isolated anomalies now appear to belong to the same large-scale structure. The pressure shifts again. The question is no longer whether the apparent network is being imagined. The observations keep reinforcing it instead of dismantling it. Each larger survey removes another reason to dismiss what the maps are showing. A new description begins taking over. The universe no longer appears organized around scattered groups of galaxies. It increasingly resembles an immense web of connected structures stretching across space. The picture has changed completely. The galaxies now look like pieces of something larger. The web does not connect them. They exist inside it. And as that picture becomes harder to ignore, a more important question emerges. If these pathways are real, why do they matter so much to where galaxies end up? The significance of the web changes once its role becomes clear. The filaments are not simply lines connecting distant regions on a map. Galaxies appear along them. Clusters grow where they intersect. Matter accumulates on the pathways instead of spreading evenly through space. The web is no longer describing where matter is. It is helping determine where matter ends up. The pattern is doing work. The web is not simply showing where galaxies are. It is helping determine where galaxies can become. What appears at first to be a large-scale structure begins behaving like part of a larger operating system. The filaments connect dense regions together, and those regions become the places where galaxies and clusters continue developing. That changes the meaning of the web entirely. The walls, filaments, and voids are no longer just shapes revealed by observation. They influence where matter ends up and where it does not. The arrangement affects how larger structures emerge across the universe. The hidden bridges are not decoration. They are part of the framework through which matter organizes itself. The maps that once seemed to show a strange visual pattern now reveal something more important. The largest structures in the universe are not scattered randomly across space. They are connected through an immense network of pathways that help shape where galaxies grow and where clusters take form. What began as an unexpected pattern on a map becomes something far more consequential. The structure is not merely visible, it is active in the organization of the universe itself.